Today in this video, I'll be explaining what is a ionic bond and a covalent bond, as well as showing how to draw a loose structure for each of them. So we're gonna start off right off with ionic bonds right here. And so we know that an ionic bond, it's like a bond between a metal and non-metal. It's like, so basically it's like the metal is giving his electron to a non-metal. And so it's like the metal wants to give, like I want here, you want man, I want to give you my electron, you can have it. The non-metal, however, is just take, doesn't want to give its electrons to the metal whatsoever. And so yeah, metals like to share electrons, that's their property about it, and non-metals like to take away. So we have an example right here between a metal, and a non-metal. So we have two lithiums right here. So I'll put this in a different color, draw this out. You have one lithium right here and another lithium right here. And so we know that each of them have one valence electron each, based on the periodic table if you'd like to check. And we know that oxygen has 6 valence electrons. So so we have two metals and one non-metal. So the non-metal here wants to fill the octet rule. He wants to fill all his 8 electrons. So by octet, it means 8. So at the moment right now, he has 6 valence electrons, you can see right here. And so if you're like wondering where I get the valence electrons on, it's basically they exist in the most outer shell. So if I were to draw draw a Bohr model for oxygen, I will look at the most outer shell and count the number of valence electrons. And so if you look at the very most outer ring, it will have 6 valence electrons in the most outer ring. And so basically that's what the loose structure is, just putting only the valence electrons only. And so to show that, an ionic bond, we would have to show that a lithium is giving its electron to oxygen. So now oxygen has 7 valence electrons now, and so it needs one more. And so lithium was like, hey, you know what, lithium, you know what, I want to give electron also. So it will give his electron as well to oxygen. And so now this is complete. So oxygen has now all 8 valence electrons. So we can write it like the final product as this. We could write it as lithium +1 because it's giving away an electron from itself. Most people like get mixed up with, wait, shouldn't it be a -2 because it's losing? Well, yeah, that in a general sense, yes, it's correct, but in this case, we have to put a positive because it's given away. Because if it's given away, think of it as like a good deed. So if you're doing like a good deed, you get a point, and so that's why you put a positive right there. But that's my just general sense if that helps you remember it all. And so oxygen we will draw now as -2 because it's stealing from these two metals, and so like it's earning you 2 bad D points. So that's what we put as a -2. Make sure you don't put it as positive because it's gaining or anything, but make sure you put -2 if that helps you in any way whatsoever. So now that's one example of this. Now let's move on to the next example. We have sodium and chlorine now. So we know that sodium has one valence electron right here. We know that chlorine has 7 valence electrons. So we can just draw it out right here. So 1, 2, 4, 5, 6, 7. So we notice that it has 7 valence electrons, but it's not there yet to fulfill the octet rule. So for it to fulfill the octet rule, it will need valence electrons, like one more basically. And so here we are. We have the sodium with this one electron right here. We only give it away to chlorine. So we can draw this an arrow right here to show that it's given away its electron. And so we can write this final product as sodium +1 because it's given away. It's like earning a good deed. And then we have chlorine, which is stealing against a -1. It's like stealing. So that's how we write at our um, ionic bond. So now moving on to covalent bonds. So covalent bonds, what's the difference between them and ionic is that they're only two nonmetals. They're not a metal and a nonmetal. And so examples of these could be like nitrogen, oxygen, fluorine. Those are nonmetals. So they're only bonding between two nonmetals. And so in a covalent bond, they're sharing. They're not like stealing from each other, but they're actually sharing. Unlike the ionic bond, which we have the electrons we can take away and transfer to the nonmetal. But we have two nonmetals, so they're the same thing. They're both the same type of element. They're both nonmetals. They like to share with each other, right? So the draw loose structure for this, we would just like first, I'm gonna write this out. So we have our hydrogen right here, and then we have our oxygen. I'm gonna put in the center, and then we have our hydrogen right over here. I like to put the oxygen in the center because it's the least amount of number. I like to put the bigger quantity of elements on the outside. So we know that oxygen has 6 valence electrons. So 2, 3, 4, 5, 6. And you know that hydrogen has one valence electron right over here. So now to show that these these three elements are binding together is we can show by this. Because since oxygen still needs to fulfill the octet rule, it needs 8, right now 6 at the moment. So to show a sharing bond, we can draw like this. Because if you count like right now we have 6, but this is 6 right now, right? But then he has extra electron he's sharing with, so it'll count as 7. So he has 7 electrons right now. And the same thing for the other one. We're drawing like another bond right over here. So then in this case it'll be 8 because if you count all these all together now, including the bonds right here, so 1, 2, 3, 4, 5, 6, 7, 8. So you can be sure to include this when you're counting, so you can tell that it has fulfilled the octet rule. So as a result, we can write it as this. I'll just draw an arrow right over here. We have oxygen, and keep in mind we also have these leftover pairs. So look, we have 2 leftover pairs right here, lone pairs, and I'll cover that in another video on what these mean and how does it affect the shape of a molecule. So, but be sure to keep the leftover pairs, leftover lone pairs on the oxygen when you're showing the final structure for the molecule. And like I said, I'll cover this in another video. So this is our final molecule. This is what it looks like. And then onto our last example, which is chlorine and carbon. So we have carbon right over here. I'm just gonna draw this right over here. We have carbon, and we have 1 chlorine over here, 1 chlorine over here, and I like to keep this like a 4x4 area. So we know that carbon has 4 valence electrons. We know that chlorine has 7 valence electrons. So we can draw as this. Like that. So now that we have filled all these in for all the chlorine, now we just show that, they need to fulfill the octet rule. So at the moment right now, chlorine is at 7 electrons. Same thing for the rest of all of them. They need 1 more electron to complete the octet rule. And so, and if you notice something, that carbon has 4 valence electrons. So if you notice, if you share with each one of them, chlorine will fulfill the octet rule, right? So if we draw a bond right here, chlorine has already fulfilled the octet rule now, because now instead of 7 as that one valence electron is sharing with carbon, so it'll count as 8. So chlorine is now 8, and same thing with this right here and so on. Chlorine is got 1 more valence electron by sharing, another one right here, and another one right over here. And so carbon has fulfilled the rule, and no, I mean chlorine has fulfilled the rule, and then carbon has nothing left to share. So in this case, there's no lone pairs left over. So we can write as this as the final thing right here. I'll just put this right here because I don't have space to show the screen. So I'll put this. So carbon bonding with chlorine, and like I said, this line represents the bond between one bond. And if it were a double, if we could say, I'll explain later. Okay, so let's say hypothetically we have another bond. Let's say we have an extra, out of nowhere, an extra electron coming over here for carbon, and we end up bonding with it. This will be considered a double bond. But in the real life, hypothetically, I'm just saying hypothetically, this is not real. Carbon does not have 5 valence electrons. I'm just making this up to give you an example. If it has 2 bonds, we will write a double line, a double dashed line, if we're writing this. So keep that in mind if you ever run to a double bond. This is the final result now. You have carbon being bonded with all 4 chlorine. And so I hope this video helps. If you have any questions about anything, just leave a comment down below. I'll try my best to my ability to answer it and help you get through it. So if you really enjoyed the video, smash a like. I'll see you guys in the next video. Peace.